Hi, welcome back to leetCode. So in this video, I'm going to discuss the third problem from today's biweekly contest 169. The name of the problem is longest non-decreasing subarray after replacing at most one element. So what is the problem statement? Problem is that you are given an integer array nums. Okay, fine. So you are allowed to replace at most one element in the array with any other integer value of your choice. Okay. Now we have to return the length of the longest non-decreasing subarray that can be obtained after performing at most one replacement. Okay, that means example 1, 2, 3, 1, 2, 3, 1, 2. Okay, so if we don't apply any operation, like if we do not want to change any number, so what is the best answer actually I can actually get? So that means non-decreasing subarray. That means it should be anyway increase. That means it should not decrease, non-decreasing. Like this is possible 1 2 to possible, but 1 to 1 is not a non-decreasing, right? You can say that this is actually same, but this is not decreasing, right? Here you can say this is actually decreasing 2 and 1. Okay, so this is actually valid subarray, this is non-decreasing, right? And this way any 1 to 3 is also a non-decreasing because it is going to increase. Okay, next is what is the best answer actually I can get without any replacement. So here you can see that this is the 1 2 3. Okay, this subarray actually it is going to non-decreasing, right? So and this actually 1 2, so maximum length actually I will get that will be 3, right? This is clear. Why actually 3 is the best answer I can get. Now if I want to apply that operation, so they mention that I can change any number with any number, change any number and with any number. Like I can change 1, I can change this 2, I can change this 3, I can change 1, this 2, right? All numbers I can change any number and with any number, right? Replaced by any number. So first of all, this is suppose I have changed to 2, 2 2 3 1 2. Is it going to change our answer? No, because again the length is 3 still. Next, suppose I have changed this 2. So when it is possible, like when it will give us a better result. Fine. Suppose this example, for this example, 1 2 3 1 2. So you can see that first of all this subarray it is non-decreasing. Again this is non-decreasing, right? So somehow if I change this number, right, or this number, then actually it is possible that it may actually give us a better result, right? So let's see it is possible or not. Suppose I change this to 1 2 2, that is still 1 2, right? I have changed this number only, I have changed this number. So it is going to increase our length? No, it is still 1 2 2 and length is 3. So if I change this number 1 2 3, suppose I have changed this 3 2, right? So you can see that when I change this number 1 2 3, you can see that our maximum length is increased by 1. This is maximum length is 4 now. This subarray 1 2 3 3, this is actually non-decreasing, correct? This is non-decreasing. Clear? 1 2 3 3, this is non-decreasing. So this is a, so our answer will be now modified to 4. Previously it was 3, now it is 4. So what is actually the case what actually I can replace? So case 1 is possible that after replacing, suppose we actually have some element here and some element in the right side also. So after replacing this element to something, suppose y, I replaced x by y. Okay, so it may possible that whatever actually the left actually length is possible, it will length increase by 1. It may possible one possible case, right? For the leftmost actually this actually the already in non-decreasing order, and if I actually change this to some number, actually the length can be increased by 1. So left plus 1, right? Case 2 is possible is that after changing the current number x to any number, so it is possible that our length will be increased by right side also, right? In the previous example we have seen that when I have to change this current number to 3, it may increase with the left 1 2 3 3 1 2 3 3. You can see that left array is same 1 2 3, and I have changed the current number only, so it is now going to a non-decreasing. So you can see that this is actually going to insert by left plus 1. Okay, similarly the right case is also possible, so that's why case 2 is possible the right plus 1, right, and case 3 possible that such a way it may possible in some cases that it will be increased by both, like it will merge both the subarrays left and right. So it will be left plus right plus 1. So how actually I can actually do that? So what is the case? So this case 1 and 2, there is no condition, because I can change whatever the number is present in the left side, just left side. Literally you can say that suppose 1 2 3, literally suppose 2. Okay, so if I change this current, this number, this is the suppose the x, this is the x. So if I change this to 3, you can see that there is no condition. If there is any element in the left side, the length will be increased by 1, right? And right side also, if I want to mark this current element to the right subarray, so it will be increased by plus 1. Clear? So just see that 2 1 2 3 4. So this is the suppose x, suppose this is the target element x that actually I want to change. So you can see that if I want to change to 1, so our array will look like 1 1 2 3 4. So this will actually increased by 1. Got it? So previously the right side, the subarray length is non-decreasing subarray length is 4 plus 1, it is now 5. Clear? For this case 1 and 2, there is no case, there is no more condition, right? We can, this length will be anyway increased by 1 blindly, right? But for case 3, is it possible to merge always? Suppose this situation 1 2 3 1 2. Suppose our x is this element. This is suppose our x. This is suppose our x. Now I want to change to any number, right? Suppose, so that doesn't matter here. So honestly I can actually merge this to subarray. This is the left and this is the right. Honestly I can actually merge this. No. Suppose if I merge this, so 1 2 3 3 2. Suppose I have changed this to 3. Okay. So is it going to insert this, going to increase our length, left plus right plus 1? No. You can see that this is non-decreasing, not a non-decreasing, right? It is going to decrease. After 3 it is 2. So if I want to replace this with 2, 1 2 3 2 2. Now you can see that this is actually non-decreasing. It is going to decrease here. 3, after 3 it is 2. So it is decreasing, not increasing, right? So this is not possible. But for this situation, suppose another case 1 2 3 and suppose 4 sorry 1 2 3 and next subarray is suppose 1 and 5. Suppose now this one is our x, this number I want to change. Now can actually merge this to subarray. This is one subarray left and this 5 is the right subarray. Can actually merge this to subarray L and R. Let's see. So suppose I have changed this x to 3. So it will be 1 2 3 3 5. Yes, all number actually it is non-decreasing, right? All the elements in subarray. You can check that 1 2 3 3 5. Okay, it's possible. So this is going to add increase our length. Next possibly suppose I have changed this x to 5. Okay, 1 2 3 5 5. Here also our length, our element, the array is actually non-decreasing, right? Correct. So the condition is that the leftmost or the rightmost element in the left array, that should be less than the leftmost element present in the right array. Correct. That means left of I minus 1, I is the target index, left of I minus 1 should be less than equal to right array of I plus 1, right? I minus 1, this is the I minus 1, this is actually the I plus 1. So actually I can merge only if the the 3, whatever the number is present, 3 is actually less than equal to the 5, right? If it is both a 3, then also it is possible, right? Clear? Then I can only merge case 3. So I have to check that. So for case 3, I have to add one more condition. If condition is that if the rightmost element of the left array, if it is less than equal to the leftmost element of the right array, then actually I can merge them, right? And why actually the increased length will be left plus right plus 1, because this left or right will merge, and the ith element or the x will be changed to 3 or the 5, any number. So that will also contribute one more element. So that's a left plus right plus 1. Clear? So how can I efficiently check that? The actually decreasing or non-decreasing. So I can actually take two like if I particular brute force approach, I can think suppose 1 2 3 1 2. So suppose I will check, okay, this number I want to check, I want to change. So if our answer is start with best answer is 3 initial, now I want to change this 1, so I can change into, so case 1 is if it can actually contribute one more length to the left side, there is any subarray in the left side? No. So case 1 is not possible here because there is no element in the left side. For now right array, is there any right side? Yes, 2 3. Okay, so it can contribute 1 plus 2, so 3. Okay, this is the best answer till now. Got it? Got it? Next is I want to check that is there any march is possible? No, because there is no element in the left side, so there is no situation to march, right? Next, I will check that this, if I want to change this number 2, okay, there is in the left side, yes, there is some subarray is present in the left side. So what is the length of that? That is length is 1. So how can I check that what is the length of the subarray of non-decreasing? So I will just go through this here from right to left, right? Means I minus 1 to 0. I'll check that whenever it is going to increase, so I'll just break from that. So I'll check that how many times, what is the length of the just right left side, just left side, right? So there is only one subarray and length is also 1, and 1 plus 1 it is 2. This is not a best case. Okay, in the right side, what is the, you can see that when it is going to right side after 3, it is when I come to 1, it is actually less than the previous number. So I am going to break from here. So length I got in the right side actually only 1. So it will actually maximum length I can get 1 plus 1, it is actually 2. This is not a best case, best answer. So I'll count the case number 3. It is possible to merge. Yes, you can see that 1 is less than equal to 3. 1 is less than equal to 3. Got it? So I can merge. So what is the left subarray length? That is also 1. What is the right subarray length? That is also 1. And what is the current element will also contribute? So 3. So you can see that this is the subarray I can generate. Okay. Next, go to this 3. Next element. So next x is our 3. Okay. So what is the left subarray of non-decreasing? Just left. That actually 1 and 2. Okay. And right subarray only 1. Okay. Only 1 and 2. Non-decreasing. Correct. 3 is the in between. So first of all, case 1, if I want to merge this current element to the left side, so length is 2. 2 plus 1, it is actually 3. Or from the case 2, means if I want to merge the current element to the right subarray, so it will be 3 1 2. 3 1 2, that means I will change 3 to 1. Right. So array will look like 1 1 2. So again the length is 3. Correct. 2 plus 1. Next, I will check that is it possible to merge with left subarray and right subarray. So left subarray, what is the rightmost element? That is actually 2. And what is the leftmost element on the right side? Right subarray, that is 1. Is 2 is less than equal to 1? No. So I can't merge. So case 3 is not possible for this 3. Okay. Clear? So still actually our answer is, best answer is 3, maximum subarray. So now our x is 1. So I'll check what is the left subarray. Yes, one left subarray is possible, non-decreasing. That is actually 1, 2, 3. This is left subarray. Right subarray it is only 2. This is L and this is R. So now case 1 is I want to mark this x to the left array, left subarray. That will be 1, 2, 3, 3. I will change this 1, 2, 3. So I got length as 4. Right, the length is now 4. So this is one best answer. So I'll override this with 4. Got it? Now case 2. Case 2. I'll mark this current element to the right subarray. That means 2, 2. So length I will got 2. But this is not a best answer, so I will not override it. Now case 3. Can I actually mark this? So what is the rightmost element? 3. What is the leftmost element in the right subarray? That is 2. Is 3 less than equal to 2? No. So I cannot mark this to subarray. So that's why case 3 is not possible. So that's why our answer will be still 4. Clear? So what is the time value for this? So you can see that x, I am trying to check all the numbers, all the possible, because I can change any number. So this can be x, this can be x, this can be x. So for that, so x, for each x, I will actually check the left subarray and right subarray. Right, left non-decreasing and right non-decreasing subarray. Right. So to check that what is the length of the left subarray and the right subarray. So suppose I got L and R, length of them. So to check that, it will, in the worst case, it will actually run big of n times some length, right? To check that what is the whenever I found any non-increasing or non-decreasing condition, so I'll break from there. So in the worst case, it will actually run with all the elements. So for each x, I have to run 2 times, one to get the left subarray, one to get the right subarray. Right. So to get the length of the left subarray and the right subarray of the non-decreasing. So for each x for that. So for each x, in the worst case, I'll run n times. In the worst case. So what is the x position, x number of possibility of x? That is also b of n. Number of position for x is actually n. And so for each position, I am going to iterate n times. So it will be n square. Yeah. So what is the n value length of the input array? Let's see. That is 10 to the power 5. So it will give us 10 because n is 10 to the power 5. So n square will be 10 to the power 10. So it is greater than 10 to the power 8, right? So it will not work. How will optimize that? Let's see. So in this case, actually, it will help us the prefix and suffix. Prefix and suffix concept. How? So you will see that anyway we need to check with all elements, right? Because x can be anything, any number can be our x, right? So we cannot optimize that. So it will actually be big of n. But actually to get the left subarray, left non-decreasing subarray and right non-decreasing subarray, we're iterating extra, right? Big of n. How to optimize that? Actually, what actually we want to know? That we want to know that what is the left subarray length and what is the right subarray length, and this is actually I. So from left subarray, actually I want to know that what is the length of the non-decreasing subarray at the index I minus 1, and from the right subarray, I want to know that what is the right subarray length, non-decreasing subarray length in the right side at index I plus 1, starting with this, right? I plus 1. So that's why here we needed 2 things. One is the prefix. Prefix is from 0 to I minus 1, and suffix to get I plus 1 to n minus 1. Right. So that's why if we check, this will actually help us to in constant time to find out what is the left subarray length and what is the right subarray length, big of 1. If somehow actually store that value in somewhere, right, we can optimize that. So then actually it will take actually big of n. right? This it will work. So how can I actually store that value? So suppose for this example, again same example, 1 2 3 1 2. So in the left subarray, in the left array, what will I will store? So in the left array, I will store that it index I. What is the length of the subarray ending at I? Non-decreasing subarray ending at I. So this is the first element. So it will initialize with 1. Okay. This is the first element. Next, I am going to can actually add this to the previous subarray. Yes, because this is non-decreasing. 2 can be added to 1. So this length will be increased by 1. So 1 plus 1, it is now 2. You can see that ending at index 1, what is the length of the subarray? Non-decreasing, that actually the 2. Okay. Next, I'll go to the next element 3. Can actually add this 3 into the previous subarray? Yes, because the previous element it was 2 and now current element is 3. So if you actually add 2 and 3, so this is a non-decreasing. So I can add this. So what is the length of the previous subarray? It is 2. 2 plus 1, it is now 3. Next, this 1. Can actually add this to 1 to this 3. 3 and 1 possible? No, this is not a non-decreasing. So again, it will start from a new subarray, right? Starting with 1. So that's why length will be now 1. Got it? Next is 2. Can actually add this 2 in the previous number 1? Yes. So our length will be increased by 1. So this is now 2. Clear? From this left array, you can see that at any index I, I can say that what is the length of the subarray ending at index I. Length of the subarray. You can see this, suppose this index. What is the length? Actually, it is value is 3. You can see that what is the length of the subarray? 1 2 3. Correct? This is valid. Clear? Suppose this index. Now I want to check that what is the subarray is ending at 1 as a non-decreasing. So only one element is present. Only one subarray is possible ending at 1. So that's why length is 1. Got it? Clear? Now similar for the right. Right means I will say from the right side. So this 2, this is the first element. So our length will be 1. Next is can actually add this 1 to the right side. 1 and 2. Yes. So you can see that what is the length of this? It is subarray is 2. Got it? So this right actually indicates that what is the length of subarray starting at I and it is actually ending at I. This left array is actually ending at I. You can see that left array it indicates that what is the length of the subarray ending at index I. Length of the subarray. Here actually you can see that this 2 actually indicates what? Length of the subarray possible starting with I. Starting with I. So I am starting with 1 here. Yes, I can actually add this 2 in the add 1 to the right side of subarray. So that's why the length is 2. Clear? Next is 3. Can actually add this 3 to the 1. Not possible because this is going to decrease that. So that's why this will be new subarray. So that's why length will be initialized with 1. Got it? Next is this 2. Can actually add this 2 to the right element? 3. Yes, because this is actually non-decreasing. So that's why what is the right subarray length is 1. And this is going to add a new element. So it will be now 2. Clear? Next is element is 1. Can actually add this to 2 because the right element is 2. Yes, this is non-decreasing. So what is the right subarray length is 2. And this will be now 3. These 2 vector is clear. Left vector and the right array. Left array indicates that what is the length of the subarray ending at I. And right array actually indicates that what is the subarray starting at I as a non-decreasing subarray possible. Clear? These 2 things, because ultimately we are trying to do that, right? Actually you can see that we are trying to find out that what is the left subarray is possible and what is the right subarray is possible. So left subarray I am going to from I minus 1 to 0. So I'll check that okay 3, okay this is a starting element. 2 can actually add this, yes. 1 can actually add this. In this I have to check that right? And for the right, I will go from to I plus 1 to n minus 1, right? So that's why I need actually two variable, two array. One is the left to indicate that, suppose I want that I am at current index I. So I minus 1, I want that what is the subarray length ending at I minus 1, correct? And in the I plus 1 index, I want to know that what is subarray length starting at I plus 1. Clear? I actually need two things. One is the ending at I minus 1. One is the starting at I plus 1. Clear? Because this is a new starting element of the subarray and this is the ending of the subarray. Clear? Now I can easily find out that I can merge this or not, because to merge that I need to know only the I minus 1 and I plus 1. Right, nums of I minus 1, it should be less than equal to nums of I plus 1. Next I can merge left plus right plus 1, correct? This is clear. So in this constant time we can actually find out what is the left subarray length and what is the right subarray length. We don't need to iterate all the elements, right, to check that this is a part of the current subarray or not, in the left subarray or right subarray or not. Clear? Now go to the code. You can it out. If you can comment on that. So first of all, find out the length of the input array. It is n, and I have to generate two array. One is for left, another right. So I will just initialize with one, left and right, because only one element can present in the array in subarray. Now first of all, generate all the possible left subarray. Okay, ending at I. So that's why I start from 1 and less than it will go up to n minus 1. Why not starting from 0? Because there is no element in the left side of that 0, index 0. So that's why we don't need to check that can actually add new subarray or not. So that's why I'll start from 1. Now for that I have to check that the current, honestly I can actually add this current number to the previous subarray only if this is non-decreasing. So what is the condition for non-decreasing? The current number, nums of I, it should be greater than equals to the current previous number. Then actually I can add this current number to the previous subarray. Right? That is the condition to non-decreasing. Non-decreasing means the current number should be greater than equals to the previous number, not it should decrease, right? It should not be decreased. So that's why if it is true, that means I can add this current number into the previous subarray. So that's why left of I, it should be 1 plus left of I minus 1. I minus 1. Whatever length of the left subarray, that should be increased by 1. Got it? That is ending at index I. So in this I will go to the till up to n minus 1. So after this for loop, I can easily say that from the left array that what is the subarray possible, length of the subarray is possible ending at I, at any index I, right? Ending at index I. Got it? Now we have to generate the right array. Or if I want to know that in constant time that what is the length of the subarray, that actually non-decreasing subarray is possible starting at index I. So what is the condition for that? I will start from right to left. So I will start from n minus 2 and it can go up to 0. I get values to 0, I minus minus. Correct? So if nums of I, if it is less than equal to the previous number or the right element, I plus 1, then actually I can add this current number to the right subarray. Clear? This is the condition I'm saying. So non-decreasing, that means 2, 2. So these 2 can be added to this subarray as the 2 is less than equal to 2. And suppose this 3 and 2, can actually add this 3 into the previous subarray. 3 and 2, not possible because 3 is greater than 2. So this is not possible. So I cannot insert that. So that's why I will check that the current number that I am going to insert into the right subarray, if it is less than equal to the right element, then actually I can only add this element to the right subarray. So that's why if it is less than equal to the current right number, then the right subarray length will be increased by 1 plus whatever the length is present at the I plus 1. Got it? Here I am starting from n minus 2 because this will increase our length if there is some element in the right side and that number is greater than the current number. But for the n minus 1, the rightmost element, is there any number in the right side? Not any, no any number. So that's why I don't need to check that. So that's why I'll start from n minus 2 and it can go up to 0. Okay, whenever the current number is less than equal to the right element, so our length will be increased by 1 plus whatever the number is present at the right side. Got it? So after this for loop from this right array, I can easily find out that what is the length of the subarray, non-decreasing subarray starting at index I. Got it? Now this answer that I have written, that what is the maximum length of the subarray, which is actually non-decreasing. So without any operation, I can find out what is the left or the maximum length actually I have in the left array, and you can also check with the right array because both will be same. Right? Something 1, 2, 3. So left array will look like 1, 2, 3, and right array will look like 1, 2, 3. Correct. So what is the maximum value? You can see the 3. So this will be our best answer without any operation. Right? Without any operation. Right? So for that, I am initialized with the maximum value is present in the left array. You can also find out extract from the right array also. Now this x, I have to fix the x. X means the target element I want to change. So that's why any number can be our change target element. So that's why it can start from 0 to n minus 1. Okay. Now for each index, I have to check that can actually merge this to the left array. So when is it possible? If there is some element in the left side, so what is the condition? I should be greater than 0. Then actually I can merge this current element to the left subarray. So for this is for the case 1. This is for the case 2. When I want to merge the current element to the right subarray, and this is case 3. When it will merge to the left and right both subarray. So case 1 is only possible if there is some element in the left side. So that's why I should be greater than 0. If it is greater than 0, that means we have some element in the left side. So our maximum answer actually I can get left of I minus 1 plus 1. So left of actually indicates that what is the maximum subarray ending at I minus 1. Alright. So that will indicate, I will get that, and plus 1. That means the current element also will be added to this subarray. So that's why plus 1. Left of subarray at the index I minus 1 plus 1. Similarly, case 2, when I want to add this current element to the right subarray, so I have to find out what is the maximum subarray length, non-decreasing subarray length at the index I plus 1. Right? So how it will get this? I will get from the right array, right? So we should have some element on the right side. So that's why I should be less than n minus 1. So it should be maximum n minus 2. I can go up to n minus 2. Then actually we have some element on the right side. So that's why if it is less than n minus 1. So I will check what is the right value, right subarray length I plus 1 at the index I plus 1 plus 1. Why plus 1? Because the current element will be going to add that. Got it? So case 1 and case 2 we have covered here, and now is the case 3. So case 3 is that when actually we can merge, I want to merge the left array and subarray, right subarray. So condition is that we have some element, we should have some element in the left subarray and we have some element in the right array. So that's why I should be greater than 0. I should be greater than 0. Okay, because we have left subarray. We have actually confirmed that. Next is we need actually have some right subarray. So that's why I should be less than n minus 1. Got it? So in these first two conditions confirmed that we have left subarray and right subarray. Now we have to check that can actually merge this or not. So what is the condition to merge? Condition is that merge that the number present at the I minus 1, it should be less than equal to nums of I plus 1, means 2 less than equal to 2, then actually I can actually merge this. 2 less than equal to 3, then actually I can merge. Suppose if it is 3 and this is equal to 2, can I actually merge this? No. How? Because the x will be changed to 3 or 2. So if I change this to 3, 3, 3, 2, can I actually merge this array? No, because you can see that this is actually anyway not decreasing. If I change this to 2, 3, 2, 2, this is actually decreasing here. So I cannot merge here. So that's why it should be smaller than that. So that's why I can merge only if nums of I minus 1. Sorry. What actually we've done here? nums of I minus 1 should be less than I plus 1. Then I can only mark that, right? So this is the only condition. And what is the length of that? For that, left of I minus 1. So from that left vector, I can easily find out that what is the length of the subarray ending at I minus 1. And right subarray, I can easily find out what is the length of the subarray starting with I plus 1. Got it? And plus 1. Got it? So I'll take the maximum value and store this into the answer. And ultimately, after checking all the x, I'll return the answer. Whatever the length is the maximum answer actually I got. Maximum length. I hope this is clear. You can see that what is the time step for this. This for loop will run big of n times. Okay, big of n. This for loop will also big of n. And this for loop, you can see that constant. This is also this for loop only run big of n times. But inside all the conditions actually constant time, right? It will take constant time. We are not iterating that what is the left subarray and what is the right subarray. Starting with index I plus 1 and ending at I minus 1. We don't need, we are getting that from the constant by using the left array and the right array. Got it? So ultimate overall time study is big of n. I hope this is clear. I have shared this code in the description. You can check that. You have any doubt, you can comment on that. And you have not used any prefix and suffix before this problem, so you can actually solve that also, because this is really important concept in the data structure algorithm. So you should actually know about that. Okay, bye.